Hello and welcome to another Construct 3 demonstration where I will demonstrate how to implement automatic zooming and scrolling when we're dealing with multiple characters. So here's the end result, what you're seeing on the screen now. And actually there's controls. If I press the 1 key on the keyboard, number 1, we're controlling this first player here, and you can immediately see what happens. The screen automatically adapts itself to zoom in and scroll to a view where all 4 players are still included in the view. And can switch to another player, for example there's one here, and that automatically happens as well. And switching to the 3rd player here, and so forth and so forth. So this is automatic zooming and scrolling. How does that work? Let's go and see here in the event sheet. So what happens here is this first event is whenever the keys 1, 2, 3 and 4 are pressed, we disable the A direction behavior of the player, of every player actually. So there's no context here, so every player is affected in this action, and the A direction behavior just makes sure that you can control the player using the arrow keys. So by default, for all of the players, the A direction behavior is disabled. But whenever we press the 1, 2, 3 and 4 key, we will pick the correct player by picking it by its unique instance number, the IID, and we do that using pick a player instance. That's pick nth instance here, and what we do here is we convert the typed key of the keyboard, which is 1, 2, 3, 4, to an integer and subtract 1, because the IID is of course 0 based, so the first one has got IID 0, second one has IID 1, etc. But we're pressing 1, 2, 3, 4, so we just subtract 1 basically. And for that player we will activate the A direction behavior, and we've also added flash behavior, so we can flash that player for a second to see which player we're actively controlling here. So, and then the bulk of the action happens here on every tick. And you can see here there's a lot of expressions going on, but I'll explain to you what's going on actually. There are some local numbers. First of all, there's padding, and we add some padding. You'll see that we'll add some padding to the player just to be able to not move him towards the edges of the screen. There's always going to be a little padding between the edge of the screen and the player itself. So the more we increase this padding, the more edges there will be at the edge of the screen. And then there's this target scale, which we'll use to go to the new scale whenever we change the position of a player. And then there's the minimum X, minimum Y and maximum Y, which we default to a very large number for the X, the minimum, and 0 for the maximum. So that's in essence actually the local numbers which are being defined here on every tick. And then we do something for each player. So you have to remember there are 4 players in this game, so this loop will happen actually 4 times. So we start with these default variables, which these default values, a very large number and 0. And then we set the minimum X. In the first iteration of this loop, we set the minimum X to, and we'll start at the middle of the expression here. By default, we would get the bounding box left of the player minus the padding divided by the layout scale. So this layout scale here is actually the built-in expression to get the current layout scale. But whenever we zoom in or zoom out, this layout scale will change. That's why we have to take into account this layout scale in order to have the correct position of the player. So what we'll do is, by default, we will pick the bounding box left of that certain player, minus the padding, taking into account the layout scale, but we'll take the minimum of minimum X and the thing I just explained. But remember, minimum X is the thing we're setting here. And we're doing that because in the next iteration of this loop, this minimum x will have changed. So by default, this is a very large number, 999999. And with a very high likely chance, this number here, bounding box left minus padding divided by layout scale, will be less than 99999. So in that case, in the first iteration, the minimum of that very large number and that calculation will be this calculation. And then we can, in the next iteration, we can check if that number of the next player is even smaller or not. If it's even smaller, we will pick that one. Otherwise, the minimum x will remain at the first minimum x, or the one prior to that iteration. And in order to circumvent that we don't have a negative value, we also do a maximum of that calculation and 0. So that's actually what happens. The minimum x is set to an expression that also uses minimum x to actually search for the most left x of all the players on the screen. The same happens here for the minimum y. So whenever we take here the bounding box top minus the padding divided by the layout scale, of course, for the same reasons, but then we see also we use the minimum y again. So whenever the minimum y of a certain player is smaller than a minimum y we already determined from another player in the loop, then it will be that number. So we get actually the minimum of that player. And the same thing happens here for the max x and for the max y, but as you see, instead of taking the minimum, we take the maximum. So we can get the most right player and the most bottom player as well. So that's actually what it works, and that's also why we start at 0 here, because the maximum of any player's bounding box right plus the padding divided by the layout scale for the first player in this iteration will almost be certainly larger than 0. And again, to not go beyond the width of the layout, we will do a minimum of that value and the layout width. Same here for the layout height. So once we got those minimum x's and maximum x's established, by looping through every player and seeing which player is the highest on the screen, the lowest on the screen, the most to the left and the most to the right, we use those variables to scroll to the correct position. Now we scroll to the correct position using the linear extrapolation. So the x and y position where we're going to scroll towards is determined by the lerp function, and the lerp function is the linear extrapolation function. I'm going to refer you to another video on my YouTube channel where I explain exactly what this means. But in essence, we're going from the current x position towards the minimum x plus the maximum x divided by 2. So the minimum x is the x position of the left bounding box of the most left player plus the right bounding box of the most right player divided by 2 to have it nicely in the middle of the 2. The dt times 16 is just the time it takes to go from this to this expression, and dt is at the end built an expression actually to make all this frame rate independent. The same thing happens for the y position, which we're going to scroll towards. We're starting from the current y position and we're going to the minimum y plus the maximum y divided by 2, which is the top of the topmost player and the bottom of the bottommost player nicely divided by 2 to go to the middle in the y perspective as well. So that's what we're doing here. And then we're going to determine the target scale. The target scale is set to a comparison. Actually, it's a ratio. So the ratio of the width of the viewport divided by the maximum x minus the maximum minimum x, and maximum y divided minus minimum y. So what this does actually, it's taking into account how far the players are from each other in respect to the height and the width of the viewport. And to retain a single number, we take the minimum, because then it nicely scales down to the exact scale where the players are all visible on the screen. So, and then we set the target scale to the minimum of 1 and the target scale, because we don't allow zooming in too close. Whenever the players overlap or come too close to another, that would be actually zooming into the player itself and not seeing its surroundings. So we will actually take a target scale of 1 whenever that target scale becomes larger than 1. And then last but not least, we will also move from the layout scale, the current layout scale, to the target scale we just determined, using the linear extrapolation once again. So it all smoothly goes into scrolling and zooming while the players are moving on the screen. So that's it. I hope you liked it. As always, please like and subscribe, and I will leave a link in the comment section where you can get this template. Thank you for watching.